polygons in the coordinate plane. Okay, so what's a polygon? A polygon is a two-dimensional shape that has at least 3 vertices. Okay, so we're gonna those are 2 words you need to know. Okay, so polygon is a two-dimensional shape. You guys know what these are. They're triangles, they're squares, they're which are called quadrilaterals. They're, oh, that's terrible. Hexagons, heptagons, octagons, all the gons, okay? All right, so anyway, we are, what we're going to do is we're going to be plotting vertices, okay? Vertices are simply where the corners meet, or where the line segments connect. It's the corners, okay? So how many corners? A triangle has 3 sides. It has 3 vertices. So this is side 1, side 2, side 3. This would be vertice A, vertice B, vertice C. And those make up these angles, 1, 2, 3. Okay, so that's how all of them work. Square has 4 of each of those. Okay, all right, so now that we know that, we need to also be able to, so those are called vertices. Vertices. I think that's how you spell it. We'll figure it out in 2 seconds. Let's figure that out. I don't want to misspell vertices. Vertices. I don't think that's what I put. I knew it looked wrong. No, that's right. Okay, vertices. Vertices are just, like I said, the corners. Okay, it's not difficult. So when we draw a polygon, all we're going to do is plot these points and then fill in the lines to make the polygon. Okay, then from that we're going to be able to find the distance. Okay, well, how long is this right here if we know where these points are, and we'll talk about that. Okay, so I want to start with, that's just an intro. Oh wait, let's see. You can find the horizontal side lengths. You can draw a polygon and solve real world problems. Okay, okay, so we'll keep going. All right, so let's draw a polygon in the coordinate plane. Okay, the vertices, remember vertices are what? The corners. Okay, the vertices of the quadrilateral are -1, 1. Okay, remember -1, 1. Remember we're plotting. The x goes first, then the y. Okay, so I'm going to use red here. -1, 1. So I go to the x. X is -1, so it goes left 1 and then up 1. So -1, 1 is right there. 0, 6. Okay, that means 0xe. 0 to the x, right or left, right? And 6, yeah, 6. 6 is positive, so it goes up on the y. 1, 2, 3, 4, 5, 6. And we got another point right there. We have another point right there. 4, 5. X is 4. So we'll go over 4. X is 4. 5 is y, +5. So it's going to go right there. Okay. And we can label these. That's always fun. -1, 1. In fact, they probably want you to do that. 0, 6. And this would be 4, 5. Okay. Now we have one more point, which is 5, -2. 5, -2. That means to the right 5, and -2 means down 2. So there you go. +5, -2 goes right there. And that'd be 5, -2. Okay, now here's the fun part. We get to get out our little shapey thing and connect the dots. Ooh, I don't like black. Let's do blue. Boom. Boom. That's terrible. Boom. Not great either, but that's okay. Boom. And you have to say boom, otherwise it's not official. Boom. We just drew a polygon using the vertices. How awesome is that? I think it's kind of fun. I don't know why, I enjoy the satisfaction of plotting things. It's fun. Okay, so that's how you do that. You basically just plot the points and then connect the dots. You guys have been connecting dots since like 3rd grade. I feel like you can do this. Okay, so now we're going to talk about finding distances. And we've been doing this since the beginning of class, in our beginning of school, so in our little pre-class exercises. We did a lot of distance finding, okay? I like to find distances. It's important. Okay, so all we're going to do is start by plotting, okay? Don't try to figure these out. Just plot, especially now until you really get the hang of it. Just plot the point. Okay, so let's start with -3, -5. That means -3, -3, -5 goes right there. So let's stick with red. -3, -5 is right here. Okay, so we have -3, -5, and we have 2, -5. +2, -5. So +2, -5. So you'll notice that either the x or y coordinate on all these is going to be the same, so that it's a nice, easy distance to find. Otherwise, we have to use a formula that's kind of more in the algebra. Probably, I think it's Algebra 1 where you start to learn that. Maybe pre-algebra. Okay, so now let's draw our pretty little line. Boop, boop. Okay, now we got to count. You can just, okay, there's a lot of ways to do this, guys. All right, so basically what I'm trying to do is forget the -5s, okay? All that -5 is telling me is that they're both on this -5 line, okay? So all I care about is this 2 and this -3, okay? So they are not in the same quadrant, so therefore it is -1, 2, 3 places to the 0 here, and then 2 to the right, so you add them together. Okay, so there's multiple ways to do this. One way is to think of it as if they're in different quadrants, you add the first 2 numbers, absolute value. If they're in the same quadrant, so if you were between 4 and 5, they're in the same quadrant, there's only 1. So you could subtract. 5 minus 4 is 1. Okay, there's many ways to do this, or the way that works always is the absolute value of the difference of the 2 numbers. What? Okay, the absolute value of the difference between the 2, okay? That works every time. So if I take a -3 and I subtract 2, I get a -5 and take the absolute value. So maybe that's more of a 7th grade idea. For me in 6th grade, here's what I would do. I would draw the lines and then I would count, because counting is easy. I start here, I go 1, 2, 3, 4, 5. The distance is 5. Okay, if you're going to take the time to draw it, you might as well use it, because that makes it really easy. You just count the numbers. If they were harder numbers, which they won't be for 6th grade, so we're good. Okay, find the distance between 3 and -2.5. Okay, so they're going to test us here. So 3 is the x, 3 and -2.5, which is halfway between -2 and -3, so it goes right there. Apparently this one's going to be a different color. 3 and -2.5, and 3 and -5. 3 and -5. Okay, and now let's draw a line. Okay, so this one's vertical. Does that change anything? No, not really. We can still count, but in this particular case, we're in the same quadrant, okay? And we've got a, well, let's write our points. I'm getting lazy here. 3, -2.5, and this one's 3, -5. So what we're worried about here is this -2.5 and -5. They're in the same quadrant. Okay, so you can basically subtract them. Okay, you can subtract their absolute values. So the absolute value of 5 is 5. The absolute value of -2.5 is 2.5. So 5 minus 2.5 gives me 2.5. So the distance between these two is 2.5. Note, it will never be negative. Distances cannot be negative. If you walk for 1 mile in one direction, do you walk in -1 mile? Do you walk -1 miles when you come back? No, you walk +1 miles when you come back. There's no such thing as negative distance, okay? At least not in any way that you need to know about. I think that would have to involve time travel of some sort or some weird astrophysics stuff. I'm sure in black holes or something like that it exists maybe, but no. For all intents and purposes, there's no such thing as a negative distance. All right. I think that's it. I know this has been long. Oh, this is modeling real life. I want you guys to do this one on your own because it's cool, because it's got a secret chamber. Like, that sounds cool. So plot the points, find the perimeter and the area. Okay, so, we're going to have to do this, aren't we? Okay, we're going to do this one. -8, 10. I'm going to move quickly, though. -8, 10 is right here. We're going to have to draw a 10 here. -8, 10. And then we have 4, 10. 1, 2, 3, 4, 10. 4, 10, and then we have, you could have done this yourself if you wanted, 4, 2, 4, 2. Note that the x values here and here are the same. That's going to help us come up with the distances, the side lengths. -8, 2. Okay, -8, 2. Notice on this one, -8, 2. That's really bad. Okay, let's try again. -8, 2. Okay, not much better. Okay, notice that the -8, -8, so that's a vertical line, and then 2, 2, so that's a horizontal line. 10, 10, so this is horizontal. So basically what we end up with a rectangle. All right, and it probably even told us we had a rectangle. So let's connect the dots, because it's cool. Ooh, that's bad. Now we're going to live with that. Pretend that's straight. Okay, now I'm going to need the side length so I can do perimeter, right? Because remember, perimeter is equal... Whoa, I got to get rid of my shapey thing. Perimeter is equal to 2 times the length plus 2 times the width, right? And then we're going to have to figure out the area, I believe is the other thing, which is length times width. So we need to know what they are. So what is this length? Okay, well, the 2's stay the same, so we have a -8 and a 4. So we take the absolute value of 8, which is 8, and they're in different quadrants, so we add them. Or we can just count. 1, 2, 3, 4, 5, 6, 7, 8, as we expected. It's 8 away there. And then 4. So 8 plus 4 is 12. So let's get our 12. This side is 12. Okay, now, what about this one here? Well, we're on 4. This vertical, or this x value of 4 on both lines. So we're going from 10 to 2. They're in the same quadrant, so we subtract. 10 minus 2 is 8. All right, so now we have 12 and 8. So that means that this is 8 and this is 12. And now it wants to know the area, which is the length times the width. Okay, so area equals 12 times, and then the width of 8. 12 times 8 is 96. So my area is 96. 96 square somethings. I'm sure they told us that. We want to label it, but I'm running out of time here, so I'm rushing it. Okay, the perimeter is 2 times the length. The length is 12. 2 times 12 is 24, so we can already move them on down here, which is equal to 2 times the width, which is 8, which is the same. Oh, it doesn't equal it, it's plus it. You'll have to forgive me, guys. I am really, really hurting this week. Starting next week, you're going to be like, this is so much better. I'm glad Mr. Hines is feeling better. God willing, I will be. Okay, 24 plus 16 is equal to 40. So the perimeter is 40. All right, cool.